Alright, welcome guys to the last example for the topic integrating factor by inspection. So this is example number 5 already. So we have already tackled the concept and then 4 examples pertaining to this particular method. So I hope you were able to watch all of the examples before this. Then actually I just prepared or um, made this last example for you to realize na it is possible to use two or more integrating factors, no? Dun sa given function natin. So, it doesn't mean na same variable lang siya. So, it can be combination of two variables from different set of terms, ano, group of terms, as long as it satisfy all of the equations, all of the terms inside the equation. Okay? So, okay, so let's solve this by first regrouping the terms strategically, no? So let's try to distribute the terms. No? So let's have x squared y dx minus y cubed of dx plus y dx. Okay, next, negative x cubed dy plus xy squared dy plus x dy is equals to 0. Okay, so that is the expanded form. Now, in regrouping, let's try to look at the first term. Okay, meron siyang x squared, no? And y. So, tingin ka ngayon na may x and y na term, no? Ito, may x and y. So, I think we can group these two together and then factor out whichever is possible. Okay, but now let's group x squared y dx plus xy squared dy. Okay, so that is this and this. Okay, next we have y dx. Okay, so look for a y dx. So this is also y dx. This is x cubed dy x dy. Okay, so where do you think we can combine um, this term, no? So natin siya pwede i-combine. So I think we can combine it with hmm, okay. So maybe the first one is I don't know. We can select this one, ano? For the first one. This one pala, no? Kasi we have x squared. This is x cubed. You can factor out x squared once you group them together. Okay, so sorry about that. So let's try to use this one. Okay, so negative x cubed dy. And then use the other with this. Okay, para you can factor out y squared. Okay, so negative y cubed dx plus xy squared dy. Then last, of course, the most convenient group, okay, y dx plus x dy is equals to 0. Okay, here we can factor out x squared. So x squared, so y dx minus x dy plus, we can factor out y squared. So negative y dx plus x dy plus y dx plus x dy is equals to 0. No? So you can see we have three types ng grouping that we have created. No? See y dx minus x dy, it can be used dito, no? Okay? Si y dx x dy naman, we can use dito. Okay? So, what I will do is, itong last term natin, it is an exact differentials of xy. Okay? So, you have to realize na dapat yung multiplier mo to make this term integratable later, no? It should have an xy. Okay? Pero dito makikita mo, kung xy lang yung i-multiply natin, okay? May matitirang isang x over y. Okay? Which is not dito, no? Kailangan natin ng may mga squared. Okay? Kailangan natin ng may squared. X squared tsaka y squared para makapag-multiply tayo or makapagawa tayo ng exact differential. So, pwede gawin natin, multiply natin siya by, let's try, integrating factor natin is, I will just add xy. It's equals to 1 over x squared y squared. Okay? So, let's try that para ma-satisfy o makakuha tayo ng exact differentials. X squared y squared. Okay? So, once multiplied sa first term, we have y dx minus x dy over x squared y squared plus dito, it will be x dy, rearranging the term, dx over x squared. So, sorry, dapat dito is wala na itong x squared. Okay? And then we have last one, d of xy over x squared y squared. It can also be presented as this. Okay? It's equals to 0. Now, so you can see now here, yung ganitong fraction, exact differential siya ng quotient na meron siyang derivative, meron siyang denominator na y, and then yung numerator niya ay x. Okay? So, please refer to the previous video on how to identify that. Dito, x yung naka-squared, so it means na meron siyang x dito, and then y dito. So, this is y. Okay? Plus xy negative 2 dxy is equals to 0. Okay? Now, it can be integrated. And, sorry, where are we? Yeah, okay. So, we can integrate it. So, we have x over y plus y over x plus xy negative 1 over negative 1 is equals to c. Okay? Now, to simplify this further, um, can now be equal to x over y plus y over x minus 1 over xy is equals to c. So, pwede natin multiply both side by xy. This can be now equal to x squared plus y squared minus 1 is equals to cxy. So, this will be your final solution for this given differential. Okay? So, as you can see, we have arrived with the three groupings, no, that we can actually identify kung what integrating factor is possible, no? But when deciding for the integrating factor, you have to account for all the terms inside the differential equation, no? Kaya dito, once we identified na these terms or this group is the exact differentials of xy, we make sure that our integrating factor contains xy so that once you integrate it here, it can be integrated, no? Kasi you cannot introduce variable once you have an integration sign na already. Okay? And then we use x squared and y squared to satisfy now the exact differential needed to arrive with these two. Okay? Kaya naging y squared. Dito, once multiplied, that is x squared over y squared. So, canceled out, kaya naging y squared lang siya. Okay? Same dito, over x squared, y squared. So, cancel out yung y squared, kaya x squared yung natira. And dito, again, that is the same as xy squared. And then just perform integration for each term. And then you have this, simplifying it, multiplying it by the common um, denominator for these terms. And then, as you can see, magka-cancel out yung y. We are left out with x. That's why it x squared. Cancel out the x, it will be y squared minus cancel out all negative 1 is equals to our arbitrary constant time xy. Okay, so by this example, I hope by now you realize na it really depends on the judgment of the solver, how you can solve it by inspection. Okay, but we already have discussed previous methods like linear equation and Bernoulli equation um, to arrive with the solution when you don't want to do it by inspection. Okay, so if you have questions regarding this example, please comment down below, and then please try to visit the concept first and then try to study also or watch the previous video example number 1 through 4 to at least um, have the feel on how to solve this kind of problem. Again, practice is key. So I hope you try to solve this on your own once you understand the solution that I have presented to you. Okay, so that's it for now. So see you guys again next time for next or new topic regarding differential equation. Thank you.